Hello CIS25, this is part 3 of Unit 2 lecture, and in this part we will explore further with networking and going a little bit into addresses. So in the notes on page 26, it begins with talking about 3G, 4G, 5G, and LTE. This is for cellular network technology. Why do you need to know this? I'm sure many of you already know the technology, but you need to service mobile devices that would utilize either 3G, 4G, 5G, or LTE networks. So G stands for generation, and each of the generation would be based on the network service that's provided by the service provider, like T-Mobile, AT&T, Verizon, and so on. It's basically pertaining to signaling and how that is being supported with the provider networks. So when you look at the table that's provided 2.7 here, you would see the comparison and the year it was released. So for the 3G, that was used for video calling, high-speed internet, and data transmission. 4G is used for live streaming, like watching TV on your mobile device, video conferencing, and improving with the speed. LTE was more on the coverage, where you would get faster speed and a wider span in the range for coverage. 5G is faster data transfer and fewer delays. So we improved the performance with 5G with the speed, but you would know that the range would be less. In the network environment, you would then look at how your systems would be client-based or peer-to-peer. Peer-to-peer means that the system would be equal in roles. Like at home, you would have like an ad hoc network where all the systems are equivalent in role. No one is controlling anybody else. In the client-based network, you would have different servers that are servicing based on hierarchical structure. So when you're connecting to the internet, visiting a website, you are using DNS along with visiting the web servers. The web server is going to provide you the content of the actual website, and web server uses HTTP to communicate with the system, and it's hosted either at the business or via a leased cloud. There would also be file servers, and file servers are used to share storage where the user can upload file and download files. Commonly in the network environment now supported with Azure is your SharePoint or OneDrive and so on. So file servers are designed to control what type of files can be transferred across the network from one system to another. At home, you might be able to implement something like network attached storage, which is a system, a computing system that would have disk, whether it's SSD, solid state drive, or hard disk drive, to be able to store files. NAS is important in that you can centralize the file storage, but not all networks would have that because of the incurring costs and maintenance. You would also have print server, and print server are designed to manage prints. So in a larger network, there will be a lot of prints, like printing receipts, printing invoices, things like that. You can use a regular computer system instead of a server system to manage print. That system would then have a static IP address. It would have the proper software to be able to manage the print for print jobs, queue, and so on. Or it could also be an advanced system like a server system with server operating system. So it really depends on the scale of the network. The HTTP server we previously touched on, it's used to assign IP addresses, and on the smaller network that would be your wireless router. DNS server is, it would contain public IP address and the associated domain. Its job is to translate the domain names that is used on web page into the requested IP address. So when the user type in the URL, right, google.com, for example, DNS would take that URL and translate it to IP address that's associated with that particular domain. Proxy server is an intermediary between the client and another network. Proxy server stores the web pages that have been requested, and if the client requests the same one, it would then check and cache the page. If the page exists, proxy server would then provide the copy to the client. Proxy server also help reduce traffic between the network and the internet. It can also be used to block requests for undesired traffic, so it can be acting as a traffic cop. It can also be used for anonymous surfing. Mail server is used for send and receive mail on the network. It would then be able to, we can use protocol like SNMP, POP3, IMAP to be able to manage sending and receiving mail, and that is through our app. Authentication server would examine and verify the credential of the user that's attempting to log into the network. If the user are permitted, the user will be granting a certain permission that will be stored on the central server with the security certificates that will allow the user to log in and access certain resources. Syslog servers are used to track events that happens to the different devices on the network, and if the devices can track, could be system devices, events, outstanding events, warning, error, crashes, and so on. So Syslog servers are very important for security specialists and professionals, along with network and also administrators and professional that service systems. Internet appliances mainly just perform specific tasks on the internet network, and your Unified Threat Management UTM provide firewall, remote access, virtual private network, web traffic filtering, and so on. On the security side, you would see intrusion detection system, and IDS is used to detect any kind of irregular activity that would pertain to intrusion or external connection that would jeopardize your network. It might also be implemented with a firewall, so you do have some all-in-one devices. Your typical threats would then be detected by the IDS, so it would raise the alarm, and it would include certain things like attack or services that would be potentially a threat to the network, malware attacks, data-driven attacks, or host-based attacks. So IDS is usually installed internally in the network in different parts of the network to be able to raise the alarm in case the attack occurs or an incident that would happen. A true IDS does not block attack because the product is really designed to identify the threats. The IPS, intrusion prevention system, is the system that prevents the attack. IPS uses methods similar to IDS, but unlike the IDS, it actually blocks attack. You would be able to configure the rules and the settings to prevent attack from happening, and you would implement software in the case where you don't use the appliance, so you would be able to monitor and block out the attack. For the end user management servers, this keep track of the devices that are on the network to make sure that it's complied to the security measures of the entire network. Endpoint users, often you would see this in a network that would have a lot of mobile devices and portable devices. So mainly it just looks at the type of system that is used by the users and how that would be aligned with the rules and the requirements of the network. So going back to the assignment, starting with number 20, what is the purpose of the proxy server? The proxy server helps reduce traffic between the network and the internet. It can be used to block requests of the desirable traffic. It can streamline as far as the performance serving a certain cache information or it would negotiate the traffic and be able to allow the user to connect to a certain area of the network that could improve network connectivity. 21, what's the difference between the IDS and the IPS? The IDS detects threat where the IPS block threats. So those are the two main things that we would recognize with the IPS, which is intrusion prevention system, and IDS is intrusion detection system. Now, when we switch back to the notes, we should talk about legacy embedded system. An embedded system can be your ATM machines, computing devices that's aimed for certain tasks. You would find this in all types of industry, manufacturing industry, where certain machine could be assembling cars, or point of sale system where it would process transaction. Could be older legacy system, you would see those as embedded system. Your smartphone is also an embedded system. Now, considering when we are updating this system, is it going to be compatible with the technology and the communication that we're integrating or we're using? How is the data is going to be able to migrate from one system to another? Does the embedded system have the current operating system, or how will we be able to upgrade or update? So we need to really look at how the transition would be and how we can maintain that system, troubleshoot that system over time. In the next section, I'm going to talk about network configuration. Previously, we talked about IP address, which could be version 4 or version 6. IP addresses are changeable when we're using dynamic address, which is assigned by the DHCP. Static address is manually input and would stay the same until it is manually changed again. But static IP address would be used on system like servers, default gateway. It would then be used on network appliances and shared dedicated devices. Dynamic, they just mean that it's constantly changing. Dynamic host control protocol is used to assign IP addresses. And so you can see here there's a clarification between IP address, subnet mask, DNS configuration, and gateway. Your IP address is uniquely used by the system to identify how to route the data to that system and from that system. Subnet mask is used to determine what part of the network is that system belong to. DNS configuration, it identifies the domain name, servers that system is connected to. And gateway is a way to identify the computer or the router or the appliance that belongs to a certain type of network. So the gateway is usually a router because it is how we can go from one network to another, hence the name gateway. Here it talks a little bit more about IP addresses and how that's used. A PIPA manages the addresses, especially when you're looking at different version of the addresses. IANA actually is the entity that provides that. A PIPA IP addresses are by default. It's a way for us to link without having a unique IP initially. IP version 4 is a 32-bit address, and it uses decimal values. So an example of your version 4 IP addresses is shown here, 192.168.5.1. An IP address could also be a version 6, which uses hexadecimal and it is longer. So since 2011, we had run out IP version 4 public address, and we started using IP version 6. However, in a network environment, you're going to see both. So if you're interested in learning more about networking, you can take CIS40A, and in that class we will focus more on IP addresses and how it's used. So here it explains on how IP version 4 and IP version 6 are different. IP version 6 uses 128-bit source and destination IP addresses, it uses hexadecimal number, so in combination we would have more IP addresses using version 6. And so in the version 6 IP address, it uses global unicast, and unicast address is how it would send out to one specific source or one certain destination. It also uses linked local addresses, site local addresses, and special addresses. And when you look at an IP version 6 address, you would see that it would be separated by the colon. Compared to versions 4, we would use the dot or the period. The compatibility addresses are used in that when we use version 4 and version 6 together. So it wants to be able to correlate both versions, and it would use the prefixes that are combined. So to view your IP addresses, you can use command prompt. So in this example, I would use Windows 10 and I simply search for command prompt, or I can type in CMD. And this will take me to Windows command prompt, and here I can type in ipconfig, which gives me the general configuration. As you see, I have different adapters, wired, wireless, Ethernet, along with Bluetooth and so on. So it will bring you to the section of your adapter, and here we would see that this is my configuration, and my IP address would locate here, and my subnet mask is here, and the version 6 address is located here. So you can use ipconfig or ipconfig /all in order to find your IP address. In Linux, you would use ifconfig, and ifconfig is similar to ipconfig in Windows, and you would be able to identify the inet address on the Linux operating system. So in the question number 22, what type of IP addresses that would be assigned to a DNS server or a database server? We would use a static IP because those are dedicated system. They're a server that would be connected. We don't want the address to change, and so we would want to use the static IP. And in 23, it asks you which class of IP address is 192.168.0.1. When you're looking at the class of IP address, you want to focus on the first octet, the first 3 numbers or 2 numbers of the address. And how can I know the range? So when you're looking at IP addresses in this section here, it shows you the range. Okay. Now in IP version 4, there are class A, B, and C. And in the class A, if your address starts with the lower number and with the 255.0.0 subnet mask, you would see that it is a class A address. So here in this section, you'll be able to find more, or you can also find this information online. So for us, when we're using 192.168.5.1, that is the first part of the address is the host, and or the network address. That would be your classification of the class. So in the higher number, the 192, that will be a class C address. In the class C address group, you would have less addresses but more networks. It's designed for the smaller networks. For number 24, when using IP version 6 address, as of the example shown here, how many blocks are present in this address? How many 0 bits are present in each block? So here you would see that there are 6 blocks of the 0 bits. 6 times 16, because they're hexadecimal number, that's going to give you 96 0 bits. So for A+, you don't have to worry about this so much, but for the Network Plus students, they would need to know. And you can find the information for IPv4 and IPv6 on page 30 and 31. Okay, here it talks about how it's addressing the version 4 and the version 6. It asks you what are the types of IP version 6 addresses. That will be unicast, multicast, and anycast. Unicast is able to send that out to from one system to another system. Multicast is from one system to many systems. Broadcast is one system to all systems, and anycast is one system to any of the system. So what type of IP, what are the types of IP version 6 addresses? There are 3 categories: unicast, multicast, and anycast. So in those type, you would have specific purpose used for the type of address. Some server would then need to go use anycast, whereas one system to another system would use unicast, and one system to many systems would use multicast, like some devices on your network. So on here in the notes, it provides more details on each type, and you can find that on page 33. In the next section, it discusses virtual private network. As we remotely work in COVID time, it is important to use virtual private network. This could be a software, or it could be a web services, or it could be a service that's enabled on a server or on an appliance on the network. There are different types of virtual private network. So the one that you see for the web services, it would use a website connection. You would authenticate to it, and it would establish the connectivity. The benefit of using virtual private network is that people will not be able to see how you connect to a certain network, or where you're coming from, or where you're connecting to. The types are Pptp, which is older. That's going to be point-to-point protocol. It uses this particular protocol, and it's designed for the smaller scale. It's going to be one system to another. L2TP is the later technology following Pptp, and IPsec is IP security. Considerably, it would use tunnel, and that would be much more secure. So Pptp uses 128-bit encryption. L2TP combined with IPsec uses 256-bit encryption. So you do have a better, higher security with L2TP with IPsec. Some businesses will use intranet-based VPN, where I would be able to connect into my work and then be able to use my system at work remotely. And then other type of service you would see would be remote access VPN. You would then connect to a website, and that would be extranet-based VPN. Vlan stands for Virtual Local Area Network. It's a way that we would group the physical system on the local area network and separate them from the rest. We can isolate them and logically not include them in certain part of the network for security reasons. So you can have 10 computers divided up into VLAN 1 and VLAN 2, and they won't be able to communicate without going through the router. There are different types of internet connections. There are cable, there are DSL, there are fiber optic options. So let's switch back to the assignment. We are going to go ahead and answer the last few questions. Visit the VPN Mentor website, and you would look at the product, and you would select a VPN of your choice for a small home business. So when you visit this website, you would see that there would be different types of VPN that's suggested. So I want you to be able to go through this page, and you would need to select the type of VPN that you would be able to use for business. And here it talks about different products that's available out there. Okay, so make sure that you check out that page, go through it, and answer the question. For 27, you can put down what type of internet connection do you use at home. If you're using DSL, you can put that. If you're using cable modem, you can put down cable. If you're using fiber optic with the cable connection, that's fine. Or wirelessly, in some cases you just use wireless network with the hotspot, and so on. So you can specify the type of network that you use there for internet. So here it gives you the description of what each one is. Cable is a broadband, and it's serviced by the cable company like Spectrum, Frontier, and so on. It is faster than your DSL, which uses phone line, and it modulates. So DSL stands for digital subscriber line, and it uses the telephone line to connect, so it is slower. There are two types of DSL, your ADSL and SDSL. And ADSL is known as asynchronous DSL, and SDSL is synchronous DSL. So when your downstream, when your download and your upload speed is the same, that means that it is synchronous. When your download speed and your upload speed are different, then it would be ADSL, in which downstream your download speed is faster than your upstream. So now you can see the difference. There are newer types of DSL, is known as your VDSL, which is very high bitrate digital subscriber line, or VDSL2. This one uses fiber optic connection instead of the phone line, and it is faster than the old DSL. So here you can see the difference. So will it be faster than, fiber optic on cable? No, it will still be a little slower, but it is faster than the older technology on the phone line. So that is illustrated there, and then the dial-up is when we would use the phone line to be able to connect, and it uses the modem, the analog modem, to modulate the signal and convert from analog to digital signal. And the fastest at the time, I think 128 kilobit per second, but the slowest was between 28 to 56 kilobit per second, crawling slow. This was very popular in the 90s. For your fiber optic is the best right now. There could be LED based fiber or laser, depends, single mode or multi-mode. In most cases, what you see is you would use the fiber network that's supported by the service provider, and then that will branch out to the sub area of the rural. Some other type of service for internet could be satellite, and satellite is line to site, so on the cloudy day sometimes you don't get good signal, or when you have blockage like trees and buildings. So satellite would use satellite modem, and you would see this with some of the service like satellite TV service and so on. Isdn is what's known as an integrated service digital network. This is an older technology, but it's still being used in some businesses, and it would use some kind of termination known as a TA. It resembled the analog modem for the Isdn. There are two types, which is going to be the primary rate and the basic rate, the PRI and the BRI. This was sold to businesses for connectivity reasons. You might still see this in the business that haven't upgraded their internet line, and also in other countries in the rural area. So what do you need to know for the A+? You need to know how to configure wireless and data networks. You need to know how to enable Bluetooth pairing. You need to know how to configure internet service provider webmail. You need to know how to what PRI is and what PRI updates would be, and PRL updates, and then also radio firmware settings, and so on. So your book has a lot of really great reference and steps on how to do that. So make sure that you check that out. On the tethering, it also walks you through the step on how to do that, either on your phone or on USB type of adapter. Line to site wireless, it also discussed that, and different network types. So there are local area network where all the systems are locally connected. In a business, everything that's local area network is going to be owned by the business. And then the wide area network, WAN, is going to be part of the ISP and the larger internet. So other networks that's not within the company. And in the LAN, you also have WLANs, which is your wireless network, and that will be an extension of the network. So on the LAN, we would use UTP cable to connect, or STP cable to connect, or fiber. And wireless side, we just use the wireless router or access point. The wide area network is for the larger, that will be multiple networks connecting together, 2 or more LANs. And this often would go into your internet service provider network. PAN is going to be personal area network, that will be your home, in which where you have smartphones, tablets, personal systems that will be connected. That could be Zigbee, Z-Wave, wireless, or Bluetooth, and a combination of those. MAN is the small version of WAN, and that would be considered metropolitan area network. You would see MAN in university and college campuses, along with civic center when you go from one area of the city to another, where they would be connecting. And WMN is your wireless mesh network, where it would consider a group of routers that will be connected wirelessly or wired, and that can range from small home networks to citywide networks. Some city, like City of Riverside, they would have wireless mesh network to provide wireless access to residents and businesses, and that's common nowadays. So the network tools that you would need to have some tools assembled for cable assembly, for cable installation, and as we did lab 1 for this week, you already experienced some of that. So the cabling tools can include cutting tools, stripping tools, crimping tools, and so on. So if you were available to come to class, you have experienced cable making. And you can also see the punch down tool that's used to install the jack in the wall for Ethernet, and then multimeter that would use to test electrical signal. So you can accumulate these tools and along with the tester, and put together a toolkit if you wanted to install networks and troubleshoot networks, especially on the physical part of the network. We also can use the loopback plug and so on. So now to address the rest of the questions, what are number 28? What are the network tools recommended for network installation? That will be your cutter, your stripper, your crimper, your cable tester. Those are the type of tools that you would need. And you can also use, loopback plug and other things that would be useful. When you get into fiber optic, you would have splicing tools and so on that would be a lot higher in price, but it's definitely helpful when you install different type of network. And this concludes my video, which is part 3 of your lecture for Unit 2. Let me know if you have any questions, and this also concludes the assignment for Unit 2. And make sure that you submit it by the end of the week. Take care. Thank you for watching the video.